Alright, today we're going to be looking at 9C notes, recursive equations and word problems. Now, a recursive equation is just a repeated application of a rule. So we're going to constantly add the same difference if it's arithmetic or multiply by the same ratio if it's geometric. Alright, so notice the form of it. You've got to have some starting spot. It's got to tell you, so like in this first example, we have a sub 0 is equal to 3. You've got to start with a value. We're asked to find the fourth term here. We're looking for the fourth term. Okay, so what we're going to do with recursive, so we have a sub 0 is 3. We want to find the up to the fourth term. So 1, 2, 3, 4. Or a sub 4, which actually is our fifth term. Okay, so what's going to happen here? We're going to be using this formula. So a sub n, in this case is a sub 1. All right, look how the formula works. A sub n minus 1, so a 1 minus 1 plus 7. So that's a sub 0 plus 7. Well, a sub 0 is 3, so 3 plus 7 gives us 10. So a sub 1 is 10. All right, so the same thing for the next one. So we've got the previous term. So we've got a n minus 1 is going to be 1 plus 7. Well, the previous term was 10 plus 7, so 17. So basically we're just adding 7 each time. You got to use the previous term. N minus 1, a sub 2 plus 7. So our a sub 2 was 17 plus 7, which is 24. And they ask us for the a sub 4, so we're going to do this one more time. So n minus 1 is a sub 3 plus 7. Well, a sub 3 was 24 plus 7, which is 31. So our answer here is 31. So notice we've got to build. With recursive, you have to build on the previous one. You can't just jump in. So if like I wanted the 10th term, a sub 10 here, I can't plug it in because I don't know what my 9th term is unless I go through it in sequence. All right, so that's an arithmetic one. Let's look at a geometric one. So this time, we know it's geometric because our ratio is 2. All right, let's ask for a sub 3. So same thing again. I got a sub 0, a1, a2, a3. Well, a sub 0, they tell me, is negative 4. All right, here again, it's going to be 2 times a 1 minus 1 is 0. So my a sub 0 term was negative 4. So a1 is negative 8. Same pattern, 2 a n minus 1, 2 minus 1 is a sub 1. Well, a1 was negative 8, so a2 is negative 16. We're just multiplying by 2 each time. So this is 2, a n minus 1 is 2. So 2, the previous term was negative 16, so this is going to give me negative 32. And since that's what I'm asking for, that's where I'm going to stop. Alright, so those are my recursive formulas. So like I said, it's not much to add, but they are the formulas given to you on the SOLs. Alright, let's look at a couple of word problems. These notes aren't going to take very long today. Alright, retirement. You invest $20,000 in a retirement plan. The plan is expected to have an annual return of 12%. We want to write a rule for the amount of money, a sub n, available in the plan at the beginning of the nth year. And then we want to find the balance at the beginning of the 20th year. Okay, so we got to think about what kind is this, geometric or arithmetic? So since we're gaining a rate, we're gaining 12% each time, that's going to make this a geometric question. And they're asking us for a rule, so we're going to need that formula for the rule of a geometric. So a sub n is equal to a1 times the ratio to the n minus 1 power. Alright, so what do we need here? We need a sub 1, which is our initial investment, which is our $20,000, and we need our rate. Alright, it's a 12% return. So that means we have our original amount of money, which is 100%, or 1, plus our 12%. So our rate is actually going to be 1.12, because we're gaining money. If we multiply by just 12%, we'd be losing money each time. And we want to gain money in a retirement plan. So that's why we have to add 1, the original amount of our money, plus the amount that we're going to get on the return. All right, so our rule. Now we have everything we need. So A sub n is equal to our initial investment, or $20,000, times our ratio, 1.12 to the n minus 1, where n is the number of years. So there's your rule. Now we want to find, all right, what's the balance at the beginning of the 20th year? So the 20th year, so n is 20. So we got 20,000, 1.12 to the 20 minus 1. All right, so we're just going to do that math to the 19th power. So put that in your calculator, and you will be able to use calculators on this. And so in 20 years, we should have $172,255. So not bad. All right, let's look at another problem. Part-time job. You take a part-time job that involves working the same hours each week. Your take-home pay for 4 weeks is $258.28. Write a rule, so this is working on A first. Write a rule for the total amount of take-home pay you earn by the end of the nth week. So it's asking you how much money do you earn each week. So the first thing we need to figure out is the money you earn per week. So we get $258.28 for 4 weeks. So we're going to divide that, and you should get, so we're making $64.54 per week. So we want a rule for the total amount of take-home pay you earn by the nth week. So this is an arithmetic. All right. So we're going to be multiplying. So A sub n is going to be the amount of money per week times the number of weeks. Now we don't have a constant add or subtractor here because you don't get money just from showing up. You got to actually work. So that's your rule. All right, part B. What is the total amount of take-home pay earned after 27 weeks on the job? All right, so we're going to take, the n is 27, so we're going to take our 64.57 times 27. So at the end of 27 weeks, you've made $1,743.39. All right, C. After several weeks, your total gross pay is $507.50. 4 weeks later, your total gross pay is $797.50. What is your weekly gross pay? All right, so you got a raise, basically. So what you're doing for this one is you're looking for the difference. Looking for difference, D. So just like we did in those previous problems from our 9A notes, it's kind of like thinking about like slope. So we're going to take the difference in our values, our money, which is your Y's. So you're going to take your $797.50 minus your $507.50. And because it's 4 weeks later, we're going to divide by 4. All right, to do that arithmetic, you should get, now your take-home pay is for per week is $72.50 per week. Okay, so just a couple of examples of kind of word problems, arithmetic and geometric, and that's what we're going to be working on in class. So if you have any questions, let me know. Like I said, notes are short and sweet today.